of Fermi level with the temperature. So coming to the variation of Fermi level with the temperature, with increasing of temperature in the N-type semiconductor, the Fermi level little bit increase. So after the further increase in temperature, what will happen? Fermi energy level going to decrease. At a particular temperature, it reaches the intrinsic Fermi energy level. So in a similar way, in the P-type semiconductor, initially the Fermi energy level going to decrease with increase in temperature. So further increase in temperature, what will happen? So it is going to increase at a particular temperature. Again, it reaches the intrinsic Fermi energy level. I show you the diagram. There it is. Wait a minute. Right. So conduction band, valency band, zero degree Kelvin temperature. With increasing temperature, we have taken an x-axis, and is we know this is intrinsic Fermi energy level. So intrinsic Fermi energy level, EF for intrinsic semiconductor. It is exactly in between the bottom of the conduction band to the top of the valency band. So with the for N-type semiconductor, we have donor energy level. This is the donor energy level. E suffix D. For P-type semiconductor, we have acceptor energy level EA. In case of intrinsic semiconductor, at low temperature, nothing but 0 Kelvin, the Fermi energy level lies exactly in between the bottom of the valency band to donor energy level ED by 2. So now we will see what will happen when the temperature is rises. With increase in temperature, what will happen? Little bit increases slightly. After that, further increase in temperature. So due to decreasing of donor concentration, what will happen? Fermi level also going to decrease. At a particular temperature, it reaches the intrinsic Fermi energy level. So at the same time, it will happen in the reverse for the P-type semiconductor. So at the low temperatures, nothing but Fermi energy level appear in between acceptor energy level to the top of the valency band at T equals to 0 degree Kelvin. With increasing temperature, so it will decrease slightly. After the further increase in temperature, the Fermi level started to increase. At a particular temperature, it reaches the intrinsic Fermi energy level. Means at high temperatures, both the N-type and P-type semiconductor act as an intrinsic semiconductor. And this is about variation of Fermi level with the temperature and donor and acceptor concentrations for N-type and P-type semiconductor. So today I am going to start the lasers, module 3. Coming to the module 3. Module 3, we have a lasers and fiber optics. Lasers and optical fibers. Optical fibers. So coming to the lasers, can any one of you tell me the abbreviation of laser? Can any one of you please tell me the abbreviation of laser? What is laser? No one responding? Please, any one of you.
Light amplification by stimulated emission of radiation.
Light amplification by Stimulated
emission of radiation.
Emission of radiation. Good. 408. Very good. So, what is the amplification in that? So, in the lasers, L stands for light and A stands for amplification. S stands for stimulated. E stands for emission and R stands for radiation. Right. Okay. Very good. But what is the meaning of amplification in that? When you observe the normal light and laser light, what you are going to observe, any one of you? What is that? Tell me the difference between the normal light and laser light. I think all of you seen the laser light. When you see the laser light, what you observe?
Normal light split అయితే సార్ లేజర్ లైట్
Okay.
స్ట్రైట్ గా ఉంటుంది
Okay.
స్ప్లిట్ కాదు డిఫరెంట్ డైరెక్షన్
Traveling in a single direction without much spreading, it traveling in a single direction. When you observe the normal light, is spreading over the room. If you observe in the room, the normal light spreading over the room, right? So that's what you are observing. So coming to the observation now again, stimulated emission of radiation. Before that, light amplification. Due to the amplification, light is traveling in a single direction without spreading much in the atmosphere. So amplification, nothing but coming to the amplification, increasing the strength of the signal. So you are using amplifier in the sound boxes. What is the purpose of that amplifier in the sound boxes? It increases the volume. Means it increases the strength of the signal. Here also same thing. Normal light we are going to amplify. When we amplify the normal light, we are getting the laser light here. So coming to the L stands for LASER. So in that, L stands for light. A stands for amplification. S stands for stimulated. E stands for emission. Radiation. So light amplification by, what is the process to amplify the light? Stimulated emission of radiation is the process to amplify the light, means to get the laser light from the normal light. So these laser light, means these amplified light having different characteristics than the normal light. So the characteristics of laser is, first thing is intensity. Intensity is very high. When the light is amplified, the intensity of the light is very high. So different characteristics than the laser normal light. Brightness, nothing but intensity only. Monochromaticity. Monochromaticity, nothing but all the laser light, when you observe the lights, all are traveling in all are produced in a single color, having means single wavelength. Coherence. So when the two light waves are in the coherence, then only we are producing high intensity light. And these are some characteristics of lasers. Before discussing about the characteristics of lasers, so what is stimulated emission of radiation, we have to know. Coming to the stimulated emission of radiation, so when we are taken two energy levels, E1 and E2, E1 and E2, E1 is the ground state and E2 is the excited state. So usually atoms occupy ground state initially. When ground state atoms are interacting with the matter, so photon energy absorbed by the atoms from the ground state or atoms are interacting with the photon energy in the ground state. So the photon energy absorbed by the atom and excited to the higher energy state. When the atom in the ground state absorbs some energy, what will happen? Atom excited to the higher energy state. This is called as a stimulated absorption. So your process to amplify the light is stimulated emission of radiation. So we have to know about what is stimulated emission of radiation. Here three processes are there. One is stimulated absorption and stimulated emission, and one more is the spontaneous emission. So coming to the stimulated emission, atoms in the ground state when interacting with the matter, photon energy absorbed by the atoms and excited to the higher energy state is called as stimulated absorption. Stimulated absorption. There are three mechanisms involved in the stimulated emission of radiation, stimulated emission. So first one is the stimulated absorption. What is stimulated absorption? Atoms in the ground state absorb energy and excited to the higher energy state is called as the stimulated absorption. So this is excited atom. So this atom is excited atom appear in the excited state. So but not this atom not stayed permanently in the excited state. It stayed some particular time called as a lifetime. So because of this excited atom, after losing some energy, so automatically the atom de-excited to the ground state energy level. So here one is the absorption process is only one, means upward transition. Upward we call it upward transition. Upward transition or only absorption. Coming to the emission process, here the downward transitions are called as emission processes. Here two types of emission processes are we are going to observe in the energy states. So one is spontaneous emission, another thing is stimulated emission. So coming to the spontaneous emission, so this atom having 416, raise the hand. What is your problem? Rule number 16. Rule number 16. What happened? If you are having any doubt, please ask, or else please respond. Unfortunately, వచ్చిందన్న చెప్పరా ఇంగ్లీష్లో. By mistake వచ్చిందన్న respond. When any faculty call your rule number, please respond. This is not one-to-one interaction. This is online classes. We don't know what exactly happened in the class. So coming to the stimulated absorption, atoms in the ground state, when absorbing energy, the atoms are excited to the higher energy state is called as stimulated absorption. Here two types of emission processes are there. One is spontaneous emission and second thing is stimulated emission. Coming to the spontaneous emission, again I am taking two energy, similar energy level E1 and E2. So this is the excited atom. So this atom having particular lifetime. It stayed only some time in the excited state is called as the lifetime. So before the lifetime or after the lifetime. So after the lifetime, what will happen? So after completion of lifetime, the atom automatically de-excited to the ground state energy level. So while in this transition, photon energy is emitted by the atom. H nu. What energy absorbed by the atom in the ground state to excited state? In the de-excitation process again, the atom is emitted the photon energy is called as the spontaneous emission. Spontaneous emission. So spontaneous emission occurred after completion of lifetime of atom in the excited state. So before completion of lifetime, one more emission is possible, that is called as the stimulated. So what will happen in the stimulated emission process? See, again I am taking two energy levels E2 and E1 to explain about the stimulated emission. Again, this is the excited atom. in the excited state before completion of lifetime. So if the same atom interacting with the matter, again some photon energy observed by the atom in the excited state. When the atom is absorbing some energy, the atom automatically de-excited to the ground state with emitting of photon energy. In the two cases, photon energy is emitted by the atom, but here two photons here one photon is emitted due to because of in the spontaneous emission after completion of lifetime this transition will occur. We are not going to stimulate any photon with the photon to the atom in the higher energy state. So that's why only one photon is emitted in the spontaneous emission. So in the stimulated emission process, it is occurred before the lifetime, before completion of lifetime of atom in the excited state. Again, the atom is interacting with the matter. When it is interacting with the matter, photon energy observed by the atom and de-excited to the ground state energy level is called as stimulated emission. Stimulated emission, in that also photon energy is emitted by the atom, but here two photons are emitted. So this process is continuously occurred between the energy levels until sufficient amplification is occurred after sufficient intense. So it is this photon energy is converting into the laser light. So this process, these three processes occurred. These two only, because the spontaneous emission is occurred in normal light only. Normal light, but stimulated emission of radiation is the source to get the laser light. But to start the in our lasers, to start the stimulated emission, we are using sometimes spontaneous emission. That's why we are going to discuss about the spontaneous emission here. To get the laser light, stimulated emission of radiation is the source. But why we are discussing about the spontaneous emission means to start the stimulated emission process in the any type of laser, sometimes we are using the spontaneous emission. That's why we are going to discuss about the spontaneous emission here. So this stimulated emission, stimulated absorption and stimulated emission is continuously occurred until unless sufficient intensity. So that high intensity light converting into the laser light. So that's why. So what is the abbreviation of laser? Light amplification. What is the process to amplify here? Stimulated emission of radiation. Is it clear? The three definitions are clear to everyone. Stimulated absorption, stimulated emission, and spontaneous emission. So one is upward transition. What is the upward transition here? Stimulated absorption is the upward transition, and these two are the downward transitions. Downward transitions. So what are the downward transitions here? One is the spontaneous emission, another one is the stimulated emission of radiation. So in the stimulated emission of radiation is occurred before the lifetime of atom in the excited state, and after the completion of lifetime, a spontaneous emission will occur. So coming to the PPT, I will show the PPT regarding the stimulated emission and stimulated absorption, spontaneous emission. And this is the PPT about the lasers. Wait. The PPT is visible to everyone, Amma?
Yes, sir.
Yes, sir.
Okay. So this is the laser topic. Wait. So a laser is a device that emits the light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. The term laser organizes an acronym of light amplification by stimulated emission of radiation. Coming to the stimulated emission of radiation is first used by Towers and Shallow in USA, but first invented laser is the ruby laser in 1960s. Marmin demonstrated the first laser, that is the ruby laser in 1960. First operated laser is the ruby laser, that is by Marmin in 1960. So coming to the stimulated emission. So first diagram, see the first diagram before absorption. So this photon energy is, we are going to give this photon energy now. Here it is, 1 second. Okay. So when for atomic system in thermal equilibrium with their surrounding, the emission of light results of. So first one is the absorption. If a photon energy H12 or H nu. So 1 2, why I am indicating 1 2? So the transition is occurred from first energy level to the second energy level. So H nu collides with an atom present in the ground state of energy E1. So here the mistakenly given here this is the E2 and this is the E1 number. The ground state is E1. So here it is the E2 instead of E1 I am given E2 instead of E2 I am given E1. Please correct it. Ground state is E1 and excited state is E2. Completely absorb the incident photon and makes the transition to the excited state E2. And this is the first diagram. It shows before absorption. So after absorption, atom in the yellow color atom appear in the excited state. This process we are calling as the stimulated absorption. So photon energy absorbed by the atom and excited to the higher energy state is called as a stimulated absorption. So after that, stimulated emission. So an atom initially present, spontaneous. An atom initially present in the excited state makes transition voluntarily without any aid of external stimulation or to the ground state and emits the photon energy. This is called as spontaneous emission. That is occurred before after completion of lifetime. So this is atom appear in the ground state. So in that process, photon energy is emitted by the atom, H nu energy. So so remember one thing only. What is the difference between the stimulated emission and spontaneous emission? Spontaneous emission is occurred after completion of lifetime of atom in the excited state, and before completion of lifetime, stimulated emission will be occurred. Before completion of lifetime, what we are going to do? Again, we are going to give some energy to the atom in the excited state. So when we are giving some energy to the atom, photon energy given to the atom, so that atom absorbing some energy, that energy and de-excited to the ground state energy. In both cases, photon energy is emitted. But in the spontaneous emission, we are going to observe only one photon energy. One photon is released in the stimulated emission. See the stimulated emission in the two diagrams. Again, first diagram shows before stimulated emission, and second one is after stimulated emission. So we are going to interact with the matter. Here, two photons are emitted. See, in the two, when you observe the previous diagram and this diagram, it will clearly shows in the stimulated emission, two photons are emitted, and in the spontaneous emission, only one photon is emitted, because we are not going to give any energy to the atom in the excited state in the spontaneous emission. In the stimulated emission, before completion of lifetime, atom observing one more energy and de-excited to the ground state energy level. That a photon having energy H12 on impingance on atom present in the excited state, and the atom is stimulated to make transition to the ground state, not voluntarily. By stimulating, so the atom is de-excited to the ground state, but this gives off a photon of energy H12. The emitted photons, the two photons are in phase. Okay, so means they are coherent. So what is coherent? We are going to discuss about the types of characteristics of lasers, and this is known as stimulated emission. Now see the differences between the stimulated and spontaneous emission. Spontaneous emission is polychromatic, means of all the colors are available in the spontaneous emission. White light. So it is a stimulated emission, nothing but monochromatic radiation, means it produces a single color. Every laser produces a single color. So it having less intensity. When you observe the normal light, the example for spontaneous emission is light emitted from the normal electrical bulb or light emitted from the LED. LED or electric bulb emitted by the photons are not in the coherence. That's why it's spreading over the room or over atmosphere. That's why it having less intensity. When you observe the laser light, all the laser lights are producing a single color with high intensity. That's why traveling in a single direction without much spreading over the kilometers. It has less directionality in the spontaneous emission, and the stimulated emission having high directionality. Spatial and temporal coherent means longitudinal and transversive coherence antam manam. Spatial or temporal incoherent radiation, but these are coherent radiation. Nothing but all the radiation, all the photons are in phase. When the two rays are in phase, we call as a coherent. The two rays are in coherent. So that will not occur in the spontaneous emission process. In this emission, light is not amplified. So stimulated emission is used to amplify the light. So spontaneous emission takes place when the excited atom make a transition to the lower energy level voluntarily, means without any external stimulation. So it stimulated emission is occurred with the stimulated emission, with the stimulates only. So stimulated emission takes place when a photon of energy equal to h12 h nu stimulated an excited atom to make transition to the lower energy level. In a single downward transition in the spontaneous emission, only one photon is released. So in a single downward transition, stimulated emission results in the emission of two photons. So example for spontaneous emission is electrical bulb or LED. So in the stimulated emission of radiation is the example for light from laser source. Okay, these are some any differences between the spontaneous emission and stimulated emission of radiation. This question is also asked in previous examination. All of you try to concentrate on the differences. Again, I am going to show three mechanisms of light emission. So first one is the absorption. In the absorption, atoms in the ground state absorbing energy and excited to the higher energy state is called as the stimulated absorption. That is called as the upward transition. Coming to the downward transitions, only two downward transitions. One is spontaneous emission and one more is the stimulated emission. So what is the difference between the two? One is occurred before completion of lifetime, one more is occurred after completion of lifetime. So which one is occurred before completion of lifetime? Stimulated emission. Here spontaneous emission is occurred after completion of lifetime. That atom voluntarily. So for example, this atom having particular lifetime, right? Wait a minute. So this is before stimulated emission and before. Wait. Sorry. See, in the spontaneous emission, we are not going to give any energy to the atom in the excited state. Okay, this atom having particular, for example, this atom having 10 seconds of time. Usually 10 power minus 13 seconds is the average lifetime of atom in the excited state. 10 power minus 30, maximum of 10 power minus 13, average is 10 power minus 7 seconds. Lifetime. Okay, so before completion of lifetime, what will happen? Stimulated emission is occurred. After completion of lifetime, this atom automatically de-excited to the ground state energy level with emptying of photon energy. Only one photon is released because of that atom only absorbing energy in the ground state. We are not going to give any energy in the spontaneous emission process. So coming to the stimulated emission, in the stimulated emission, before the lifetime, this process occurred before the lifetime. So before the lifetime, what we are going to do? The photon energy we are going to give to the atom in the excited state. This photon energy absorbed by the atom in the excited state and de-excited to the ground state energy level with emitting of two photons. These two photons are within the phase. Means these two photons are incoherent. And these are the differences So after the differences, we are going to discuss about not characteristics. After that, we are going to discuss. Now coming to the population or some definitions in the lasers. Basic definitions involved in the laser. Coming to the first one is population. Population nothing but the number of atoms in a particular energy state is called as a population. How can we define our country population? How can we say the population in our country? The people living in the country or the people stayed in the country is called as a population. Like that in that atoms or in that energy levels, how can we say that? How can we say the population? The number of atoms in a particular energy state is called as a population. And these 4 atoms we call as a population in the energy state E2, E1, and these are the number of population in the E2, and this is called as a population in the E3. So usually the population along to the the lower energy state having more number of atoms than the higher energy state. Here also I am representing the same. So for example, here 5 atoms we are going to observe in the E1. So E1 is more number of atoms than the E2. At the same time, E2 having more number of atoms than the E3. The usual occupation of population. So coming to the population, again I am telling the population. What is the population? The number of atoms in a particular energy state is called as a population. What is the usual occupation of atoms in our population in various energy state? So lower energy state having lower energy level having more number of atoms than the higher energy state. That is usual occupation of population. If N1 is the number of atoms in a particular energy state E1, and N2 is the number of atoms in a higher energy state, and N3 is the number of atoms in the excited state E3. So what will happen? What is the condition is N1 is always greater than to the N2 is greater than to the N3 and so on. So when it is reversed, it is called as a population inversion. In getting the laser, achievement of population inversion is compulsory. After achievement of population inversion, we are going to get the laser, or we are going to see the lasers in between the energy levels. Up to now, all of you remember only what is population and what is population inversion. Coming to the population, the number of atoms in a particular energy state is called as the population. So coming to the usual occupation of that population is lower energy state having more number of atoms than the higher energy state. Try to remember that. Coming to now population inversion. Population inversion nothing but the number of atoms in the excited state is greater than to the lower energy state is called as a population inversion. And this is the usual occupation of population. When we see the E1, E2 and E3, then here we are observing usual occupation of population. Nothing but N1 is greater than to the N2 and greater than to the N3. So when we getting the number of atoms in the E2 state is greater than to the E1 state is called as a population inversion. That is possible with the pumping mechanism. Using the pumping mechanisms, what we are going to do, then atoms in the ground state is excited to the higher energy state. By sending the atoms from the ground state to the higher energy state, we are going to achieve the population inversion. Means the number of atoms in the excited state is greater than to the lower energy state is called as a population inversion. N2 is greater than N1. When we are getting like this, N2 is greater than to the N1, or else N3 is greater than to the N2 or N1 is called as a population inversion. That is achieved with the pumping mechanism. What we are going to do in the pumping mechanisms are using the pumping sources. We are sending the atoms from ground state to the various energy states, various higher energy states. By sending the atoms from lower energy state to the higher energy state, we achieve the population inversion. After achieving the population inversion, we are getting the laser that we will discuss later at the time of types of lasers. Okay, try to remember now. Coming to the population and population inversion, again population nothing but the number of atoms in a particular range state is called as a population. And the usual occupation of population is like this. If N1 is the number of atoms in the ground state and N2 is the number of atoms in the first excited state and N3 is the number of atoms in the second excited state. So N1 is always greater than to the N2 and N3. Always N2 is also greater than to the N3. But when we achieved N2 greater than N1, sorry for the disturbance. So due to network issue, unable to connect them. So is it clear to everyone up to that? The three definitions are clear to everyone.
Yes, sir.
Mechanisms: stimulator emission, stimulator absorption, spontaneous emission. So after that, we discussed about only one definition like population and population inversion. So is it clear to everyone that population and population inversion? Please raise the hand if it is clear to
Yes, sir.
everyone.
Yes, sir.
Only 4 is responding always. 9 also. 6, 13 and 52. So laser is very interesting topic, Amma, and interesting and very easy topic also. Okay. So coming to the some topics in the laser, first we are going to discuss some basic mechanism involved in the lasing action. That is called as the stimulated emission. So to start the stimulated emission in any type of laser, we are using spontaneous emission. That's why that topic also we covered. And basic definitions involved in the laser, sir. First one is the population, and this one, sorry, population and the population inversion. When you observe these two diagrams, These two diagrams represents clearly. First diagram is normal population and second diagram is population inversion. Same E1 and E2. We observe the population inversion between the two energy levels. So means the number of atoms in the E2 state is greater than to the E1 is called as population inversion. Okay. So after that, metastable state. One more definition is metastable state. Coming to the metastable state, so to achieve the population inversion, the metastable state is compulsory. So coming to the metastable state, where the atoms are spending maximum time. So where the atoms are spending the maximum time, that state we are calling as a metastable state. Coming to the metastable state, so when we have taken three energy levels, for example, three energy levels. E3, E2 and E1. So to achieve the population, for example, atom stayed in the ground state initially. By using the pumping mechanisms, we are sending atoms to the higher energy state E3. So after that, by de-excitation, atoms are stayed E2. So to achieve the population inversion nothing but the number of atoms in the E2 state, N2 is greater than to the N1 is called as the population inversion. To achieve the population inversion, so metastable state nothing but in the metastable state, atoms spending maximum lifetime, where the atoms are spending maximum time in their lifetime is called as a population inversion. Due to spending of maximum time, atoms are stayed maximum time in the E2 state. Using the pumping mechanism, we are continuously sending to the higher energy state, and due to the de-excitation, they are appear in the E2 state. So what we are going to observe here, the number of atoms in the E2 state is greater than to the E1 state. Here we are going to observe. That is possible with the metastable state. So what is the purpose of metastable state here? So where the atoms are maximum spending maximum time, that state we are calling as a metastable state. All of you try to remember where the atoms, in which energy level atoms are spending maximum time, that energy state we call as a metastable state. To achieve the population inversion, that metastable state is compulsory in every type of laser. So remaining definitions we are going to discuss in the next class.